Now that we have shown that the slope formula is true, we need to figure out what can we actually do with that. And what we're going to master is our ability to use the slope formula to verify geometric relationships, which means parallel lines or perpendicular lines. We're also going to be mastering this standard G4C, which is about verifying that a claim is true or false with a counterexample. So we're going to be bending this a little bit to say we're going to be proving claims are true or false. As always, before you start your work, name and share it properly. The instructions for this assignment are to watch this video, which is happening right now. Great job. And complete the notes on slides 4 through 7. Then read the motivational words on slide 8. Once you are motivated, complete the practice problems on slides 9 through 13. If you're on a Chromebook and you want to watch this video in split screen, here is the command for that. And let's begin. Now that we have proven the slope formula, we can prove that a claim is true, or we can prove a claim is false. And there's three types of claims that we can prove. The first claim is that two lines are parallel. This means they have equal slope. Second type of claim we can prove is that two lines are perpendicular, which means they have negative reciprocal slope. Reciprocal meaning you flip the fraction, negative meaning you make it negative. And the last thing that we can prove is that two lines are neither parallel nor perpendicular. This means that they do not have equal slope or negative reciprocal slope. So to prove or disprove these claims, there are three steps. The first thing we need to do is find the slope of both lines. Second thing we need to do is see if slopes are equal, negative reciprocals, or neither. And once we know that, then we can determine if the claim is true or false. So let's look at some examples of this type of problem. Determine if the claim is true or false, and we're going to show our work. So the claim says line 1 containing the 0.51 and 85 is parallel to line 2, which contains 3, -4, and 6, 0. So the first thing I'm going to do is determine what is my x1, y1 point, and then what is my x2, y2 point to find the slope of line 1. So I'm going to say that x1, y1 is 5, 1, and x2, y2 is 8, 5. Now I can use that to find the slope of line 1. I would take y2, which is 8, minus y1, 1, and divide that by x2. Wait, let me back up. My y2 is 5. It's meant to happen. Divide that by x2, which is 8, minus x1, which is 5. That is going to be equal to 5 minus 1 is 4, divided by 8 minus 5 is 3. So the slope of line 1 is 4/3. Now for line 2, I'm going to say that the point 3, -4 is x1, y1, and I'm going to say that the point 60 is x2, y2. Now, I'm going to find the slope of line 2. I'm going to say y2, which is 0, minus y1, which was -4, divided by x2, which was 6, minus x1, which was 3. This is going to be equal to 0 minus a negative 4 is the same thing as adding 4. So 0 plus 4 is 4. And then 6 minus 3 is 3. So the slope of this line is also 4/3. So my conclusion is that the claim is true because both lines have equal slope of 4/3. So because they have an equal slope, that lines are parallel, which means that the claim was true because the claim said that the lines were parallel. Example 2 says line 1 containing the point 8, 2 and 2, -4 is not perpendicular to line 2, which contains 7, -2 and 1, 4. So again, the first thing I'm going to do is find the slope of line 1. So I'm going to set 8, 2 equal to my first point and 2, -4 equal to my second point. Now I'm going to find the slope of line 1. My y2 value was -4 minus 2, which was my y1 value. And I'm going to divide that by x2 value, which is 2 minus x1 value, which was 8. This is going to be equal to -4 minus 2 would give me -6. Dividing that by 2 minus -8, well, that would give me -6. And I know that -6 divided by -6 is 1. So my slope of line 1 is 1. To find the slope of line 2, I'm going to set 0.7, -2 to x1, y1. I'm going to set the 0.14 equal to y2 and then find the slope. So y2, which was 4, minus y1, -2, divided by x2, which was 1, minus 7, which was x1. That's going to give me 4 minus -2 is the same thing as adding. So that would be 4 plus 2, which is 6, divided by 1 minus -7 would give me -6. I know that 6 divided by -6 is -1. So I know that these two lines have negative reciprocal slopes. And if we look back at slide 4, negative reciprocal slopes means that the lines are parallel. But my claim said that the lines are not, opposite negative reciprocal would be perpendicular, not parallel. Opposite negative reciprocal slope would be perpendicular. My claim says that they're not perpendicular, but I just found that they have negative reciprocal slopes because 1 is the negative reciprocal of -1. So my conclusion is that the claim is false because the lines have negative reciprocal slope. This means they are perpendicular. The claim said they were not. I found that they actually were. The last example we're going to do says that line 1 containing 7, 1 and 4, -2 is neither parallel nor perpendicular to line 2, which contains 0, 5 and 8, 3. So what I need to do is find the slope of these lines to see if the claim is true or not. To do that, I'm going to set 7, 1 equal to x1, y1, and then 4, -2 equal to x2, y2 to find the slope of line 1. So I would do -2 minus 1, that's my change in y, divided by 4 minus 7, that's my change in x. -2 minus 1 gives me -3, and then 4 minus 7 also gives me negative 3. So the slope of this line is 1. Now I need to find the slope of line 2. So I'm setting the first point equal to 0, 5, and I'm setting the second point equal to 8, 3. And when I find the slope of this line, I would do 3 minus 5 divided by 8 minus 0, my change in y, divided by my change in x. 3 minus 5 would give me negative 2. 8 minus 0 would give me 8. So if I were to simplify this, I would get a slope of negative 1 over 4. So I'm looking at the two slopes. The first slope was 1. Second slope was negative 1/4. So these are not equal, and they are not negative reciprocals of each other. So I know that they're not parallel and they're not perpendicular, which means the claim is true. The claim is true because the two slopes are not equal and they are not negative reciprocals. That tells me that they are neither parallel nor perpendicular. That was the last example that we're going to do together. So now I need you to read the motivational words we have here on slide 8 and then try the practice problems on slide 9, 10, 11, and 12, and 13. Make sure you are showing your work and writing a conclusion that tells me if the claim is true or false.